started again, so we have a nice clean one to post to the YouTube archive. Hello everyone, and welcome to the 11th day of Handmade Hero, the series where we code a complete professional quality game from scratch right before your very eyes, and we explain every last little bit of it. So for those of you who want to follow along at home, you will know everything that goes into it and why. Now, we have some exciting news. There's a little bit of a caveat to the news, but we have some exciting news. People have been asking for forums and official forums where they can post things and discuss stuff with other members of the community. It is finally ready. I won't say that it's good yet. My web skills are low. I am not a web programmer, and I also tend to get very frustrated anytime I do anything with the web, and there's a lot of cursing and this sort of thing. And so I can't promise you that this site is going to be great overnight. It'll probably take a while to iron out the kinks, but if you go to handmadehero.org and hit the old F5 key to refresh it, you will notice that the link that used to say email a question, where you just had to send it directly to me, now actually has a news and forums button that you can click on. And when you go there, you will go to this little Handmade Hero Central thing, and it's got a little news that shows you like the schedule now. That's up there, so if you want to know what the schedule is going to be for the week, you can get to that. There's an episode guide that was put together by some awesome folks, Jace Bennett, Abner Clembre, Matthew Vandevender, Gustavo Chavez. I don't know how to pronounce their names correctly, so I apologize for that. These are people that I only know over the internet. I've never heard them even say their name. That is how nice they are. They've put this together for you, and this is pretty awesome. You should check out the work they've done. It's amazing. You can jump to one of these things that one of the videos from a day, and they've made this stuff where they put notes in here when there's notes for the stream, but they put basically like time-coded information where you can just click on the thing you want to know and it jumps to where it is in the stream. So it's pretty amazing. The episode guide is amazing. They've done some amazing work there, and I cannot thank them enough for that. And then, of course, there's a coding resources section that you've got that we're going to be putting stuff in, like recommendations from people. And like if you want to know how to get things running on Linux, for example, David Gao has put together an awesome guide for that, complete with source code. And then finally, there's code discussion that you can click on, and it is a full-on old-school web forum. And I'll be trying to clean up some of this. It's a little messy right now, but hopefully that'll give something, get people being able to use something in the short term while we try to clean things up a bit. So that is all the news. I hope that you find that to be usable, and if you don't, please post in the forums and we can discuss maybe changes we can make. I'll do the best I can. Like I said, I'm not a web guy, but I'll do the best I can. Last but not least, we have changed so that the pre-order button now goes to Stripe as well. A lot of people were having trouble with PayPal, I guess. I didn't realize how much better Stripe was than PayPal. It's much better experience too. I tried it out. It's way better. You can still use PayPal if you want to, but that changed as well. So we did a bunch of work on the website. Thank you to everyone who contributed to that. It's been awesome, and that is hopefully it'll all go well. Please let us know if you have any trouble with it, and we'll do the best we can. So that's it for the preamble to the stream. Welcome back, everyone. I hope you had a good Thanksgiving if you're in a part of the world that celebrates that. If not, I just hope you're having a good a good beginning of December, let's say. Tonight we have a very interesting topic to talk about, a very important topic to talk about, and that is that up until now, we have basically been doing everything in Windows. We have been essentially getting ourselves into position. If we go into our Handmade directory here, we can see that in our code directory, all we have is a Win32 Handmade. And if you remember, I prefixed it with Win32 because this is Win32 code. One of the things that I like to do, and this is very germane to the topic today, which is starting to get things into cross-platform setup, is basically I like to make it extraordinarily clear where the platform-specific code lives and where the platform-independent code lives. And so I, right from the beginning, when we did this, made sure that I specified that that was a Win32 underscore Handmade because I like to underscore each particular thing with the platform that it is made to go on. So if there's no underscore platform identifier at the beginning of it, that means that it's generic code that should compile on everything. And if there is a platform-specific prefix to it, then that means it is only for that platform. And one of the things that this allows you to do very quickly is for anyone who's trying to port it, they immediately know exactly what they have to do. They can just do a dir Win32 star kind of a thing, and they can see immediately exactly all the files that they're going to have to port for their operating system. And that's a big help to anyone. If you've ever actually ported something to a new platform before, you know that just figuring out what you have to port is a huge step, and if the person can set you up for success there, that's a big deal. But point being, we do not have any platform non-specific code at the moment. We were only working on getting a bootstrap up and running. So the first thing I want to do is just talk a little bit about what is in this Win32 file, what we are going to do with it, where it is going to go, just to kind of give people a little bit of kind of a heads up as to what to expect. Because I've seen a lot of people who've done things with the Win32 platform layer and have been talking about things with the Win32 platform layer, and I want to make sure that people don't have the wrong expectations for the code that is in there right now. So I'm actually going to slap a to-do at the top of this, just so people know exactly what's going on here. My keyboard is a little off center. That is not going to happen. That is not going to stand. All right, there we go. Let's see. This is not a final platform layer. And basically what people need to realize is what we have done with our Win32 platform layer, and this was by design, is basically I just wrote the bare minimum stuff in here that we were going to need in order to get ourselves off of Win32, in order to make sure that we basically don't have to think about Windows much anymore going forwards. So I focused on the simplest possible thing we could do for educational purposes, which was getting a sound buffer up that we could write directly into, a graphics buffer up that we could write directly into, and rudimentary input coming in from a gamepad and a keyboard, because that is mostly what we need. There's one other thing that we'll need, which is file I/O, but I saved that for this week for reasons that you'll see a little later. But what that means is I do not, and one other thing, which was timing, knowing how long things take, and we did that as well. So the thing that I want to impress upon you, though, just before we go any further, is this is not a platform layer that you would ship. And anyone who was, going crazy in the YouTube comments, oh my God, he's doing this, or he doesn't understand that, everyone can just relax a little bit. I would not ship this as a Win32 platform layer either, at all, by any stretch of the imagination, but that is not what it is for. Later on in the series, when we start doing work on getting the game shippable, when we start doing that polishing work that we need to do to get the game shippable, that is when we will be concentrating on the correct way to do everything in a Win32 platform layer for maximum compatibility, maximum performance, things like that. But right now our goals are different. Our goals are understanding and education right now, and so the last thing we want to do is spend a ton of time going, here are the 8,000 things you have to do in order to do thing X on Windows properly, because really that just obscures the real point of this series, which is the educational process. So Win32 platform stuff we will get to later, but that is not the goal right now, and so I want to make sure everyone understands that and doesn't read too much into the platform layer code as it is right now. So I'm going to write in a big to-do list and just kind of say the stuff that later on we'll probably be doing, just so you have an idea of exactly how much stuff we will actually have to go and tighten down when we finally want to ship this, so that you have no illusions about that. So saved game locations is one example. So that's basically like if we have state that we want to save, and we will, where does that go? We have to interface with Windows to find out where that goes. Getting a handle to our own executable file. That is something we'll have to do through this layer. We need the asset loading path, so we got to know where our assets are going to come from. We basically have to have threading, multi-threading, so how to launch a thread. We don't have anything like that right now. We've only got one thread, so if our game wanted to have more than one thread, it couldn't do that right now, so we're going to need that as well. We are going to need raw input, probably. We would like to do some things with raw input, support multiple keyboards, that sort of thing. Support for multiple keyboards. There we go. My keyboard is not aligned properly. There we go. You got to get that alignment or you can't get the speed. You got to get your hands in just the right place. You know what I'm saying? You know what I'm saying. All right, anyway, we have to do sleep and time begin period in order to make sure that on laptops and other sorts of circumstances we do not melt the processor down by using all available cycles and basically burn through the person's battery. Clip cursor for multi-monitor support. Because basically right now if we were to go full screen, and I should put full screen support as well. If we were to go full screen, people could move the cursor outside the window and it would be weird even though we're not getting the mouse and that sort of stuff. Let's see here. We want to be able to do WM set cursor as well, so that we basically control the cursor visibility. There we go. We are going to want to do query cancel autoplay, assuming that that even still works anymore, but something that we probably should do, at least for the old days. WM activate app for when we are not the active application. That's a good thing to do. We are going to need to do blit speed improvements, possibly using BitBlit. We are going to want hardware acceleration, so OpenGL or Direct3D, or both, potentially. Who knows? We could get totally crazy, depending on how things are going. And finally, we may want to do some stuff with get keyboard layout for French keyboards, WASD, basically international WASD, and that sort of stuff. International WASD support. And that is just a partial list of stuff. So basically, that is something to keep in mind. So hopefully that just gives you an idea of how much stuff we actually have to do when we really want to get things into complete shipping state. And we don't need to worry about most of these things for a long time, but it's just worth noting that you should understand what we are doing here is just a very simple layer designed to get us up and running so we can develop the game. And then later, as we go, we may implement some of these when we need them, if we actually need them to do stuff very specifically beforehand. We need to do that. But we also will do them at the end when we're actually just doing ship testing and we're testing on machines and seeing, okay, this didn't work here, make sure we support this there, that sort of thing. Okay, so now that I've got that out of the way, and you understand what's going on in this Win32 Handmade file, the main topic for today, the main topic for Monday, is basically how to architect code properly so that it is as easy to make cross-platform as possible. So basically what we're looking to do here is we're looking to make it so that the majority of the code that we write for this project, as much of the code as possible, will be simple for anyone, including myself, but anyone who wants to get running on another platform optimally. So basically there's two goals there. There's just the getting it running at all on another platform. So we wrote it on Windows, we want to get it running on Linux. We wrote it on Windows, we want to port it to Raspberry Pi or something like that, right? Whatever we want to port it to, there's just the act of getting it working. And we want to make that be as easy as possible. But then we also have to think about the act of making it optimal on those platforms, meaning the amount of work that that person is going to have to do. And optimal's probably the wrong term. No piece of code is ever optimal for real. But basically getting it to the point where it's performant, where it runs at a reasonable frame rate for what one might expect the game to run on that platform. So if the platform should be able to run the game at 60 frames a second, but there's a bunch of stuff with the platform that'll have to happen in order to enable that, in order to make that work. What we need to do is say, how easy are we making it for that person who has to do that port? How easy are we making them, making their lives at that time? And now, in this case, it's going to be us. We're going to be doing a lot of those ports. So it's really saying how easy we're going to make our lives. But in general, when you're working on stuff like this, it is typical that you will not be the person, perhaps, that's doing all the porting work for something that you work on. So really, you're kind of trying to keep another person in mind in some sense. You're saying, what will the people who come along here and port this to other platforms, what will they have to do? How easy will it be for them to do their job? How easy will it be for them to maintain that port when you update your version of the source? Does that going to require a whole rewrite for them? What's going to mean, right? So those are all the things that I want to put in your head, things that you want to think about, and we're going to talk about ways of making that easier and harder today so that you can see why certain decisions cause problems and why you shouldn't make those decisions and instead prefer things that are going to be a little easier. Okay, so the first thing that I'd like to say, or rather like to introduce you to if you haven't seen it before, is how people in general used to make code be cross-platform. And I shouldn't say people in general, I should say maybe the most prevalent way in the old days. So the most prevalent way in the old days is you would have a file, and that file would be doing something like our Win32 Handmade would be doing, and there would be something like the code for opening a window. So if you look at the code for opening a window here, you can basically see that we have some stuff that we had to do in order to get that to happen. It was right here. Now, the way that people used to do porting to various platforms before is they used to say, well, okay, when I need to do stuff, I'll start at the beginning here, and I'll say, well, you know, I'll use the preprocessor. And now, of course, for those of you that don't know, because we haven't talked about it much, in C and C++, there is a preprocessor, and what that preprocessor does allow you to do, along with the one thing that we have been sort of using it for in the past, pound include and pound define, which we've seen, it allows us to do pound if statements, and the pound if statements can take two forms that are kind of equivalent to some degree, but they can take different forms. Basically what we're allowed to do is say pound if and then some preprocessor expression. Like for example, pound if is running on Win32. And basically what it'll do is it'll execute the stuff in here. Stuff in here happens when that thing is 1, or sorry, not 0. And stuff in here happens when it is 0 or undefined, basically. So what this allows you to do is define basically sort of macro variables which control certain parts of the compilation so that you can knock parts out when you're on certain platforms and bring other parts in when you're on certain platforms. And so what a lot of people would do is they would define some kind of variable. Typically it would be something like that, because I believe that was the Visual C standard, was basically underscore Win32 or something like this. But you know, it could be whatever. Maybe we'd have our own, for example, like Handmade Win32, and we probably will do something like that for other reasons in a second. But basically what they'd do is they'd have it defined like that, and then inside the code you would basically bracket the things that did not work and provide alternatives. So WinMain obviously would not work on Linux, but you know what would work on Linux? It would work if you were to do something like this, right? This is the way that you would introduce that function in Linux. So something that you would see a lot of times is basically this kind of porting. Oops, I made that a little bit odd there. Basically what you'd see is something like this, and when you would compile this, if you were running on Win32, it would put in the WinMain that looks like this, and if you were compiling on Linux, let's say it would put it in here, and these could even stack on top of each other. There's an elif, basically, which could do something like this, and then we could do, you know, another one down here for a different platform, Handmade Mac, right? These sorts of things. I don't know, it's probably the same on Mac, honestly. I don't quite remember, but, well, actually on Mac you want to be in Cocoa, so it's actually an Objective-C and this sort of stuff. But point being, you would see, you know, maybe Raspberry Pi or whatever and stuff like that. Point being is you would see a bunch of stuff like this, and basically what you would do is in each one of these slots, everywhere in the code, you would go in and slot in the thing that you want to have happen. Okay. So basically, let's say that we had done something like that. We've done something like this, and now we've got something that's going to have the correct introduction for whichever platform you would have. Then what you would do is you would go into your build.batch file, and in here you would basically use what's called a compiler, you know, like a compile time pound define. And the compiler basically allows you to do that. You can specify -d, and then you can put the thing you want to define and what you want to define it to in a syntax that looks like this. -d handmade win32 equals 1 means that now I'm injecting that pound define so that anything in the code that does this kind of an if, it will get back a true, essentially. So it will actually do this line. So if I do this compile, yes, I would like to save that build.bat. If I do this compile, you will see that it works. On the other hand, if I was saying for some reason that we were compiling in some other thing, let's say I said we were compiling in Linux or something, you would notice that we would get an error essentially because it's going to actually use this other definition. So it's just a regular function and there's no H instance and all the rest of this code doesn't work, right? But you can see the basic trick here is this is what you do, and you would continue this process to port the whole function. You'd pound if all the Windows code and put else's around it so that you could inject whatever the correct calls were on Linux. Hopefully that makes pretty intuitive sense to you. It's not very complicated, right? It's a pretty basic thing to want to do. There really isn't a lot going on there that's confusing. So I'm going to go ahead and change it back to our other pound define so we can see that this thing works properly, you know, exactly what we want, because we may want to use that in the future and so on. So that is how you'd have done it way back in the past. I remember reading through like the GNU make source code back in 1996 or something, and it's just all over the place, this sort of thing, right? All the code has multiple paths. Now, the reason that I do not recommend writing code this way, and we will use I'll show you a very specific place where I do think that this comes in handy. So I'm not saying don't ever do it, but I am saying think long and hard about doing this sort of thing. The reason for it is because, first of all, it does cause a problem for exactly what I said at the very beginning of this podcast. I'm sorry, the very beginning of this video cast, I guess. This is not a podcast. I don't think anyone with an iPod could be listening to it. The very beginning of this video cast. What I basically said was, we're trying to make the job very easy for the people who have to port it in the future. And if what they have to do is go through all the code, looking for all of the places where we used Win32 code, and pound ifing around them like that, and we just scatter the code everywhere and just do the pound if, that creates a pretty big problem right there. It's just annoying. You can't see where they are up front. You don't even know where all the code is. It's a learning process just for the person to even figure out what was going on. And it forces them kind of into this mindset of, all right, I got to go look at these other sort of if statements and see what each path was doing and whatever. So that's thing one. Thing two is that the code quickly becomes very difficult for anyone to read without basically the benefit of a editor that collapses them. Because if you imagine in here, we have this sort of nonsense going on all the time, right? And remember, it's not just that, it's everything. It's every platform that this thing will ever be pointed to, right? We've got all this sort of garbage going on, right? Then pretty soon, you're basically starting to require, right, a development environment that can understand these ifs and know which ones you have set and show you only the selective code, because otherwise you're never going to be able to read this code. You're only going to see one line of each function at a time because the whole page is going to be taken up with this kind of stuff. And that's just inconvenient right there, and there's a high probability, like Emacs, if you do a bunch of stuff, does actually do that. It's kind of a pain, so I don't do it. But a lot of editors don't do it at all. There's a number of reasons why you don't want to foist that on someone. You're basically putting a hard requirement on their editor, and I'd rather not do that for such a small thing. But those two things, the first and the second one, are small compared to the third one. The third one, I saved the best for last. You know I would do it, and I did. The real reason that you never write code like this unless you absolutely have to is because it dictates the control flow must be equivalent across all platforms. Okay, I'm going to say that again just so you know what I mean, and then I'm going to give an example. If you do cross-platform code this way, it means that the control flow of your program is shared across all the platforms that you will ever ship on. Now, what do I mean by that? Well, what I mean is, if I'm going to go through here and henpeck out lines of code, like I was doing, then essentially what we have is the same set of functions and the same set of if statements, the same set of while loops, and we have just started inserting, very insidiously, different escape mechanisms, escape hatches, if you will, for each platform to go and actually do the thing that they wanted to do at the time that they needed to do it, right? That is very, very problematic when you start talking about platforms that are very different in the way that they expect initialization and platform services to work. So for example, let's say on one platform, in order to load resources asynchronously, so I want to basically have background streaming in my game. I want to load bitmaps out of my resource file, and I want to do that while the game is running. I don't want to stop the game. I want it to happen continuously so there's no loading screen. On one platform, maybe that's best accomplished with a separate thread. On another platform, maybe that's best accomplished with overlapped I/O. Who knows? Maybe it's best accomplished with memory mapped files on one platform. Each one of these things may dictate a very different structure for how the game starts up, how it continues running, how it handles things like messages that come in from the operating system, all those sorts of things. And so what I would like to impress upon you, and this comes from many, many years of shipping cross-platform code, I guess at this point it's 20 years of shipping code that always had to run everywhere, is that it's just a very inefficient way to try and do the coding. The much, much better way is the way that I'm going to show you now. So I would highly recommend not doing this method of coding. I'm going to show you two more methods for the rest of the stream here, and I would highly recommend, unless for some reason you really love what I just showed you, you really loved this right here, I would highly recommend not using that method as a method of programming, except in one specific instance that I will show you in a minute. Okay, so what are the better ways to do this? Well, I've already set us up for success with one of the ways. And this is common, I shouldn't say one of the ways. Basically, the way that is common between the two methods that I'm going to talk about next. What I did was I called this Win32 handmade.cpp. And my expectation is that somebody else will come along at some point and create Linux handmade.cpp, right? That someone's going to be me, but like I said, in a larger project, it would probably be the platform expert for Linux, whoever's job it is to make that be running. Now, the way that this will work then, right, is that the Win32 specific code will go into these files that are marked Win32, and there might be more than one, it doesn't just have to be one, multiple files with Win32 underscore, and all of the Linux code will go into Linux underscore files. Now the way it will work from there on is we will create a single shared header file that'll be called handmade.h, right? And this single shared header file will basically include the operations that the platform layer is supposed to be able to perform on behalf of our cross-platform code, right? It will create basically an API in this, it'll sort of create our own platform abstraction API in this header file. And all of our platform non-specific code will call into it this way. So basically we, let's say, have something where we want to load a file. We will type something like load file, right? And there's a name for the file. This is not the actual API we will use, but let's say we have that. We will call this load file. And oftentimes what I like to do is call it platform load file so that we know that we're asking the platform for something. They typically get prefixed, right? There will be one definition of that here, right? And it'll do the load. I guess it's got to actually return something probably, blah, blah, blah. But anyway, you get my idea. There is a platform API here. Then what happens is that API exists both here, right, inside the Linux version. And so in the Linux file, right, I would do, this implements the Linux file loading, right? And then in the Win32 version, I would do the same thing, right? I would basically have this for the Win32 version here, okay? So all that happens now is when we're actually writing platform non-specific code. So let's say we are in handmade.cpp, right? I open up my handmade.cpp. No, I do not want that. I want that. There we go. In handmade.cpp, I've got some stuff. I don't know what function this is, but I want to load a file. And I don't want this code to be relying on Windows because I don't want any more of the code that we ever write to be relying on Windows. I want it to be completely cross-platform. I am just going to call platform load file with the file name, right? I'm going to ask it to load that, and it's going to give me back the file contents like that, okay? And this is the structure that we are going to use from now on. So if you imagine this is our main loop or something, I don't know exactly what it is. This is how that goes. Then what I'm going to do is I'm just going to call into that from the platform layer. So once we have started things going, right, once things are running, I am going to call in here when we're actually up. I don't know where, we're going to clean up this thing in a second here, but so after we do, whatever their sound buffer, who knows, we're going to call this main loop thing, right? We're going to call it from in here, okay? And I have to obviously include this file, so let's do that here as well. This is something I'll talk about in 1 second as well, handmade.cpp. And I will go ahead and include handmade.h in here, like that, and I will compile. Okay, so in here we have to actually pretend that we implemented that, at least a little. So now what I want to show you is basically, I'm going to talk a little bit, well actually I'm going to talk at length about what I just did there, but in the intro, just before I go into that, I'm going to show you exactly what I mean now so you can be 100% clear on that. So basically what's going to happen is we start off in the platform-specific layer, right? The platform-specific layer is still controlling just like it was when we were Windows only. It does all of the Windows startup stuff that it was going to do, right? It does the same things, but then when it's ready to actually do game work, right? When it's ready to do game work, it calls into the platform non-specific layer of our code, where all the rest of our code will live basically from now on. Then, whenever it gets to the point where it needs a platform service again, when it needs to do something that only the platform knows how to do, file I/O, network I/O, graphics display, whatever it happens to be, then it is going to go ahead and call out, right? That call out then goes right back in to the platform layer. That platform layer fields the call, does the Windows-specific, Linux-specific, Mac-specific thing here, whatever that happens to be, returns back, and things continue as normal. Okay? Now I said I was going to talk about two ways. Right now I'm talking about just the basics that is going to be shared between both ways. This is, I would argue, the more common, more modern way of doing cross-platform code. I don't think a lot of people advocate for doing the first method that I talked about anymore. I don't think you would see a lot of people strenuously arguing that no, it's better to have all these if-tests throughout the code. I think this, what I said right there, would be relatively uncontroversial. You never know, programming things somehow seem to be controversial even when you think they wouldn't be, but I suspect you would not get a lot of people going, no, you need pound if-tests everywhere, that's fantastic. So now we get to the two possible ways of using the technique that I just described, which creates sort of two different philosophical camps for how the platform code should be written. I fall into the latter camp. I think most people fall into the former camp. So I am not going to tell you that one of these is wrong and one of these is right. I am going to tell you which one I prefer and why. But I would recommend that you think about them yourself, try them yourself if you don't have experience with them, and decide for yourself which one you would like better and do that one, because I do not have it is not an ideological war with me. I am not going to go 50 rounds with someone telling them that one is better or one is worse. I can just tell you which one that I prefer, and then you should make up your own mind about which one you prefer. So, first, before I go into those two, I'm going to tell you a little bit what I did with the build here, because it's a little crazy. And I realize that. This is something that will be highly controversial, I guarantee you. But again, not even arguing for it, just telling you how I code. Normally, the way people like to do build environments is when you have more than one file, which you almost always do, you start adding those files to this CL line here. And now most people actually have a much more complicated build system than this. So actually what they do is they have like a whole make system that lists a bunch of files and then figures out what their dependencies are and which ones have to be rebuilt, and then calls CL multiple times once for each file that's to be built, or all these other sorts of things. Many different things. You can spend forever looking up build environments. If you are interested in build environments, I recommend that you do so. It will not be something I ever cover on this stream. So there you go. You can go do that on your own. So that is what would normally happen. Even if you were using a minimal build process, you would often come in here and add handmade.cpp onto the build line, and you compile it that way. I don't like to do that. I find that just basically takes longer to compile. So what I do instead is I do something that a lot of people call the Unity build. And it's a little confusing because it has nothing to do with Unity, the game engine, which is what people probably think of when they hear Unity build. But actually what I am talking about is the concept that you just only have one conceptual translation unit in your entire project. And what that means is basically Win32 Handmade is the only file you will ever compile on Win32. And Linux_handmade.cpp is the only file you'll ever compile on Linux. Reasons that I like this. I like it because it means getting the build working on a new platform is absolutely as dumb simple as possible. You literally type the compiler and the platform file name and it builds. That's it. There's like nothing else that can go wrong. I mean, sometimes if you require these sort of things like I did here and you don't try to do automatic determination of the platform, then you have to be able to do that. That is really about it. I like how dumb simple that is. I like how it means that you won't spend any time fussing with your build environment. The other reason that I like it is it means you never have to forward declare anything if you don't want to. H files are largely optional at this point, because since everything is in the same translation unit, basically if you just stack things up in the order that you expect to call them, it kind of just works, and you can get rid of all the duplicate typing that you have to type for forward declarations. It's a minor benefit, but it helps. The other thing that I seem to notice about it is crazy fast compared to how long it takes to compile things not doing it this way. I feel like there's just a lot of startup time for the compiler, a lot of overhead in including things. I don't know. I don't pretend to know the reasons for that because I've never worked on a commercial compiler. So I couldn't tell you, but all I know is it is a lot faster to compile a single file than it is to compile lots of files. That just seems to be the case. And I have not found a situation so far where that hasn't been the case. So you get a speed win too, and I'm all for that. So that is what I did right here. Instead of doing basically putting Handmade in here, I stuck it in here. We're going to be getting a little more formal with how we do that, but for now, that's really all we need to do. And so that is pretty much how you would set up the build for now and forever. That's really the end of it. That is how I will be doing it pretty much till the end of the project, I suspect. Okay. So let's talk about the two philosophical branches we can go down, and I'll tell you the one I'm going to be going down so that you understand the differences and can see them. All right. So one way, and I'll start with the way that I think is more prevalent today so that you can understand the way that most people, I think, do this. So one way to do the cross-platform code is basically to virtualize the operating system out to the game. Now, what do I mean by that? What I mean by that is that instead of thinking of the game as sort of an isolated entity and that the platform code is working with the game or any of these sorts of things, Instead, what you're thinking of is just literally abstracting the literal operation, the specific operation of the platform. Abstracting that into a virtual set of calls that your game can call as if it was running on that virtual operating system. So what that normally looks like is after you enter WinMain, for example, you will call game main, right? Well, you won't call it that way, but you'll call game main. And then inside handmade.cpp, you will have game main, okay? And then what will happen in game main is you will start calling the platform layer to do various things. Platform layer open window, and you will tell it to open a window for you, and you will get back a platform window, like this kind of a thing, okay? You will then say platform layer open sound device, or something like this, open sound device, right? And you will get back a sound device. And I'm making these names up, but this is basically it. You will then go through and essentially do all of the startup code that you would normally do for an operating system if you were writing in that operating system directly, but instead of ever actually calling an actual operating system and asking it for something, instead you are always calling a virtual operating system that you have made up in your head, right, and defined in some H file, and then it is doing the work behind the scenes necessary to do all the stuff on actual Windows, actual Linux, actual Mac OS X, right? You're actually calling all of those things, and it's doing the work behind the scenes to make it appear as if you were running on this magical operating system. At the end, you would have game shutdown, and game shutdown will do the same things. It will do platform close window, right? That sort of stuff. I don't know why I was calling this platform layer. That's not what I said it would do. You will be doing things like this, right? You will call platform close sound device, right? And hopefully this is all pretty understandable what this would be doing. Basically, if you look back at our Win32 Handmade, you can already sort of see what would happen. This platform open window call, we would go in here and we would take this code, right? This code here that opens a window. We would extract that code. We would put it inside the platform open window call. We would take the hwind. We would wrap that in this platform window struct, make it opaque. And then basically we would have a virtualized version of all the things that we did in win32handmade.cpp. Make sense? It's very straightforward to do. I don't think you would run into a lot of problems if you want to try this yourself. I feel like, there isn't a lot of nuance to it. It's fairly straightforward. So if you want to try that and that way sounds attractive to you, then you can go and give that a shot. Like I said, I do not want to be ideological about it, so I would not say don't do that. If that seems like the way that you would like to do it, you should give it a try. And it should be fairly straightforward. It's exactly what I just said. You take all of the things that you were going to do and you abstract them. Now, I'll give you a little hint in case you want to do this, since I won't be spending a lot of time talking about that method because we're not going to use it. You may ask, how do you return the opaque stuff, right? How do you do this platform window thing? Well, the way that you do that is actually pretty straightforward. You can do something like this inside handmade.h, right? You can call, in fact, I'll just go ahead and do one of these for you just so you can see. Because like I said, if you end up feeling more comfortable with this method, I highly encourage you to do that. You should always program in the idiom that feels most comfortable to you. You should not program in a way just because I said so or somebody else on the web said so. That's a poor reason to choose a particular way. So just in case you want to pick this method, I'm going to show you how to do a couple things in it. I think that's a good idea. That way people will be set up for success if they choose to go that route and don't have any experience with this. Okay, so if we were to do this and we want to do the open window thing, right? We would do something like this. We would declare struct, but we wouldn't say how it is. So we'd basically just do a declaration. We would never define the struct. We would just declare it outside here. I'm going to get rid of the platform load file because that doesn't actually exist anymore. That was just my example there. So we're going to say platform open window, and maybe it passes, let's say, the title to the window that it wants to open. I don't know what it's going to pass here, but other stuff, right? Whatever you wanted. Maybe you want the dimensions to pass. Whatever you think you want to pass there, you pass. Okay. And then I have another thing, which is close, platform close window. And that's going to take that same window handle, right? That same window handle, and it's going to close the window. So what we do then is inside our Windows platform layer here, right? We would implement those by first defining the platform window in here, right? Because one of the interesting things that you have to remember is the Win32 code is only going to be compiled on Win32, and the Linux code is only going to be compiled on Linux. That means we can actually have two different definitions for platform window, right? We can have two totally different definitions for platform window that don't actually have to be the same. So we can, in our platform window here, right, we can store the hwin handle, right? This is the handle. And inside our Linux one, right, in our Linux one, we'd do exactly the same stuff, right? But instead, we would do whatever the X thing is here. I don't remember, but I think it's capital window or something like this, right? That's like, or you know what? I think it's that. I could be wrong. In fact, on X, you may not even be able to do some of these things. You may not even be able to use window, because I think they do some crazy stuff like that. I'm not sure. I don't remember. I wrote my X platform code a while back, and I haven't looked at it since. But point being, there's something that goes here, right? And it's whatever the X Windows platform handle is. So this is the X Windows window type would go right there, right? So then you just put the code in there, right? You create a new one of these, right? So you're going to have to allocate it, right? Whether with malloc or whatever you want to use for allocation. We'll be talking about allocations a lot, and I'll show you how I want to do them, but however you want to do your allocations is fine. So you allocate it here, right? And you make one of these things. This is the result. You then do all this code that you were going to do, and the create window, you know, this equals, the handle equals the result of create window here, right? And then you just return that, okay? And then in here, when you get a new one in, you just look, is it valid? If it is valid, you would do your close window, right, on it or whatever. You'd ask window to do it, and that'd be it. So it's really, really straightforward if you do want to do this. Basically, you just wrap up the types in your own opaque handle. In your platform non-specific part, you just don't tell them what it is. You don't let them know at all. They have no idea, so they can't accidentally use it and start creating platform-dependent code. And then on each platform, you define a version of that struct that encapsulates the things that you need, and you're done. And that's all there is to it. It's really nothing more complicated than that. So hopefully that makes some sense. We're not going to do that, but if you did want to do that, then you would be off to the races. So you know you're good to go at that point. So let me make sure we're back to normal here. I'm trying to get rid of some of this stuff. So that I don't leave old demo code around. Get rid of that, get rid of that, and now we are back to square one, I believe. Let's just verify that we are back to square one. We're still running right. Everyone is happy, I assume. Yes, it does appear to be. Why is that? Why are we going nuts there? That is not a good dead zone at all. Why are we scrolling like that? Oh, does it look like, what's going on? Did you see how crazy that was scrolling? What was going on there? Oh, yeah, it looks like the controller just wasn't initialized yet, so it was giving back some I mean, it was pseudo-initialized? I don't know. It's kind of weird how these X-input joysticks behave. When we get to Windows shipping code, I wonder if we'll have to do some stuff there, or it may be just because we haven't implemented any dead zone handling or something, I don't know. Maybe it's nothing to get concerned about, but it was a little wonky. Point being, we don't need to care about that at the moment, though. All right, so hopefully that all made some good sense, and if you would like to go out and implement your platform layer that way, hopefully you can kind of see how that would happen. It's really not that complicated to do. You just start going. Okay, I don't actually like doing things that way. The reason that I don't like doing things that way is that it is a more expressive interface excuse me, than necessary. And what do I mean by that? Well, an operating system is designed to do all sorts of things. It's designed for applications that want more than one window. It's designed for applications that don't want a window. It's designed for applications that will open windows, open windows again, close windows again, open windows again. It's designed for applications that show up in the start menu, that appear in the taskbar, that do all sorts of things like use the component object model and want to be able to embed themselves in other applications and use object linking and embedding, register themselves in the registry, integrate into the shell. An operating system supports a huge amount of flexibility, and one could argue that that's fine. We don't need to criticize the operating system for doing that. Maybe that's the operating system's job. But when it comes to a game, we do have to ask ourselves, do we need that flexibility? Is our game going to be opening multiple windows? Is our game going to need to open and close windows, open and close them, open and close them, open and close them, of its own volition, right? Not even in response to an operating system message where we could just handle it in the operating system layer, but does the game need to know that those things ever happened? Does our game need to even know what a window is? Does it care what a window is at all? Does it need to know about sound devices, or does it only want to give us back a stream of sound, right? And what I usually argue is that you don't want to add all that complexity to the platform layer if you don't have to. What I'd much rather do is define things the other way around. Instead of the platform layer being a series of services provided to the game that the game then constructs a running application out of in much the same way that a normal Win32 application would use the operating system directly, I prefer to think of the game as services to the operating system level to produce the graphics and sound necessary to play the game. Now let me show you what I mean by that. What I mean is that really, when we look at this platform layer that we've already written, there isn't much of a compelling reason to abstract any of it out of this code and allow it to be callable from the game layer. And in fact, you might actually argue that there are reasons not to do that. And those reasons are that when we actually start to tighten the ratchet on this platform code, there may be lots of very complicated logic that we need to do in order to most carefully adhere to the standards for that platform. There may be tons of Windows messages like device change that tells us we need to move to a different monitor at that time, right? There may be things like device removed, that the gamepad got unplugged and then replugged again, right? There may be all sorts of special things about like this device is a pen and so the pen should be treated this way but only in certain circumstances and depending on whether you're active at the time or not. If you think about all those things, they're different for every platform. Every platform is completely different when it comes to these sorts of things. There's a lot of very important differences. Compare and contrast something like Cocoa and the code that you write on Mac OS X with the code for, say, Linux. It's very, very different. And so what I would much rather do is just write all the operating system code and let it be all tangly and weird and do all the things that it needs to do specific to the operating system. And then the only thing the game ever does is respond to a few very simple requests, which are, give me the stuff you want to draw, give me the sound you want to play, and here is the user's input, right? If you think about it, there's really only 3 things that it needs to provide. And then on the back channel, there's really only 2 things you ever need to provide. Please send this out the network for me, and I need to read or write from a file now. Not a whole lot there, right? So what I would argue is you can drastically simplify the degree to which your platform layer inherits the complexity of its operating system by not forcing it to pass that complexity onto the game and round trip all of the logical operations through it. Hopefully that makes some sense. Now I'm going to show you how we do that. Basically, all we have to do is isolate a few specific locations in the code where the platform layer wants services from the game, and then isolate a few specific parts in the game where the game wants services from the platform layer. Okay, so for example, when we are in here, right, you will notice that we have a while loop, and this is our global running loop that we wrote. We process our messages here, we get the input from the gamepad here, right? And this was test code, but it's not that far from being regular code that we could ship. There's things we would definitely do to it, but it's sort of getting there, right? Now you see I've already kind of suggested to you what then should go on. Well, this right here, render weird gradient, that's our renderer, right? That's the thing that we rendered. Now we just have a faux thing sitting in there, but that's basically the thing that renders for the game. So I can just say game update and render right here and say this is where it's going to do its updating and rendering, right? And what I expect this to do right here, I expect this guy, oops, I'm going to put a little note in here, right? Note Casey, services that the game provides to the platform layer, right? Game update and render is one of them. And I don't even know if we're going to need any more of them at the moment. That may be it. Maybe there'll be some more, right? And then here we're going to have services that the platform layer provides to the game, right? And we're not even going to fill those in yet because that's stuff like load file, and like I think I've said before, if you happen to read my blog, I'm a big fan of semantic compression, or basically compression-oriented programming, which means you should never write something in before you actually have it working. And you should never like presuppose that an API works a particular way. You should always pull out and develop the API from the ground up. So we happen to know this is exactly where we would want to do our stuff. So I'm okay with saying that, game update and render. But then after that, I think we're pretty much done with that. I don't want to presuppose anymore. So I should actually almost say to do here. We'll add those in as we go. Okay. So basically what we want to do here is we want to say the game update and render, right? We want that to basically do the rendering into that bitmap that we set up. So we should probably pass the bitmap here to the game so we can draw into it, right? And then we also want to pass it the sound. We want to basically pass it a buffer so we can get sound back, the sound that we're going to play for this buffer, right? So we're going to do those two things. And then at the end of it, it should pretty much do the output. We've got all our output working. We've got some timing code in here. We should probably take this stuff out for now because we don't actually care about this printf at all. So I'll get rid of that for now. There we go. I don't know what display the value here is. That's some old comment. Comments are always out of date. As Jonathan Blow says, comments are always out of date. Wow, we got a lot of comments that are out of date here. Sorry to jump in here. I think Iker Murga wrote in and was mentioning these. We did change to using a lower latency already. We already did that. Yeah. Oops. Oops. Yeah. Let's see. Do we have sine wave? Yeah, switch to a sine wave. Yeah, we've got a lot of things in here. We did switch to a sine wave. We're not taking our to-dos out after we actually do them. We should start to look for that. But anyway, so, okay. Sorry, back to the story as it goes. Sometimes you got to stop and just go, what's going on in there? What is going on in there? All right, so basically, all we need to do is we need to have our game update and render basically needs to provide us a new bitmap and a new piece of sound, and it needs to take in the input, right? So we need to pass it essentially three things, right? Game update and render needs to take three things. It needs to take the input, right? The controller keyboard input, right? It needs to take the bitmap to output, right? And it needs to take the sound to output, right? It needs to take the sound buffer, the bitmap buffer. I guess I should say to use instead of to output, right? So it's going to take the controller keyboard input in. And you know what? Let's call it four things. Let's Spanish Inquisition that, because we're also going to need timing. Because if you were doing a locked timer, if you were going to have a game that had a fixed frame rate, so it always ran at 60 frames a second, then that's all you would need, right? You wouldn't pass any timing information into it. But in this particular case, since we are not doing that, we're going to do a flexible frame rate for the game. We need to pass in some timing information so the game has any idea what's going on. So at the outset, we pretty much only need these things. Now this may, I'm going to put a note in here, this may expand in the future to like a sound on separate thread, etc. In the future, we may want this to be more complicated. The calls may go from 1 to, say, 3 or something, right? Because what we may want to do in the future is we may want to have it such that we can have sound run on a different thread and get updated asynchronously or something like this. And so we may want to have the game support calling it back in less of a monolithic fashion. But we're not going to do that until we actually know that we need it. All right. So basically all we're going to do is if we run the game now, we can actually, we've had a regression essentially, right? We've gone backwards in functionality if we run the game now. And the reason is because I took out our call to render gradient, correct? Like if I look at this, there's no more gradient because we're not calling it anymore. So basically what I want to do, just to end the stream today, now that we've kind of seen the way we're doing platform services, is I would like to basically pull out our first piece of platform independent code, which is render weird gradient. Because if you look at it, you will notice that there is almost nothing about it that is platform specific. This Win32 off-screen buffer is really the only part of it which that is true. So I'm going to go ahead and just pull that straight out, right? I'm going to go ahead in here and drop into my Handmade .cpp, and I'm going to stick that in here. And you can see the only thing that we really need to do is we need to change this Win32 specific thing to a non-Win32 specific thing, right? So all we really need to do is go here and take this struct, right? This struct that we had, and we need to make that something that is not platform specific. And really, it almost already is, right? It almost already is something that is completely platform non-specific. So if we take a very trivial step here, right? We do game off screen buffer. We've got our blue offset and our green offset there, right? Got game off screen buffer, and we pass the buffer in to this. Then we will be able, and I'm not saying this is how it should necessarily go in the final thing, but we are sort of starting to get, usually code goes through a couple of transformations first, so just be aware of that, but you can kind of see what I'm doing here. We'll start, actually I guess I want to do int blue offset and green offset. Basically what I want to do is just make it so, 5-minute warning, almost out of time. Good thing we're almost done. I want to make it so that we can at least get something rendering before the end of the stream, so that you can see the first step in platform independence. So basically all I need to do now is make it so I have one of these to pass. Oops, get rid of those ints. So really all I need to do is make sure that I can pass one of those to this. And we can even do that in place here. We can just say, okay, game off screen buffer is some kind of buffer. The buffer has some memory, right? That memory comes from our Win30 screw off screen buffer. We've got the width, we've got the height, we've got the pitch, right? And where were those guys? Those guys were in our, where did it go? It's in our globals here. Darn you, 5-minute warning, you're using up my screen real estate. Global back buffer. That was what I was looking for. All right, so global back buffer dot memory, global back buffer dot width, and dot height, like so. Just pulling those out there should be good, and then we just pass the address of that, and there we go. Now if I run this, you will note that we're almost back to feature parity. We've almost got it back to the place where we had it before. Now we can achieve feature parity pretty easily by passing blue offset and green offset here, right? If we wanted to do that, we could easily do that. So basically if we said for some reason that our thing had this, then we could easily have feature parity, which we should probably do just for the end of the stream, just for fun, like that. Let's see here. What is it actually called? What is it called? I thought it was blue offset and green offset, but apparently it is not that. It's X offset and Y offset, right? Because we were doing the two different ones. X offset and Y offset. So X offset, Y offset. Okay, render that. And now we should have back our controller, and we do. Okay. So I hope you can see how easy that is, right? It's very, very straightforward. That was not like a sleight of hand or anything for those of you who are unfamiliar with platform independent programming. Really, it is that simple. We'll have to do a little bit more here. We're going to get a little fancier tomorrow, obviously. But it is really that simple. All you have to do is define a rigid boundary and then move things across the boundary from the specific side to the non-specific side as necessary. And pretty soon you'll be at the point where almost all the code you write will be on the non-specific side anyway. You won't need to write them in Windows. But that's really all there is to it. It is not very difficult to make very clean, very nice cross-platform code. A lot of people don't, but that I think is literally just because they haven't had the experience and don't know just how easy it is, because it actually is pretty darn easy if you just have a little bit of discipline to keep it that way pretty much through the entire project. So there's that. So basically what we've done is we've essentially nuked our render weird gradient call, right? It's gone now. So that is one nice big chunk of code that got moved out, and we're left with mostly code that's specific. The sine wave will be the one that we'll do tomorrow probably, and then we'll look at moving the input as well. But we are well on our way here at the end of the stream on day 11 to essentially having a cross-platform game setup ready to go. And again, this will allow basically anyone who's trying to follow us on Linux or Mac OS X to go use, oh, you know what? This might be a good time just before we get to the Q&A to give a shout out to David Gao, who has been doing some porting work. If you go to the forums, there is under coding resources already, even though this section is kind of under construction. There is a platform page, and David Gao has contributed a little handmade penguin thing. Basically what he does is he follows the stream and he shows you how to do the same stuff using the simple direct media layer, which is basically a cross-platform abstraction of windowing systems so that you can run on Mac OS X and Linux and so on. It is a very well-respected library, the SDL is. A lot of people ship games on it. So if you were looking for a library to use to help you run on a platform that you didn't understand, or if you just want to use an abstraction layer in general, that is probably a decent one to use. But anyway, point being, he has ported that stuff, and again, you can get to that link pretty easily just going to coding resources. It's right there. So if you are following along at home, we are basically at the end of this week. We will probably have pulled most things out, and we will be in platform non-specific land, so you can follow along at home exactly like you could if you were on Windows. So hopefully that has given you a little bit of a background in the philosophy of cross-platform development and how it should work. I've given you 3 different ways you could do it. I've recommended one of them, but you are welcome to look at the other 2 and see what you think of them yourself. Practice them a little, maybe, see what you think, and come to your own conclusion. We will be continuing with this tomorrow at 8 p.m., and I think now might be a good time to go into the Q&A. Obviously, as always, if you would like to have a copy of the source, you can pre-order it. You can pre-order it from handmadehero.org right here if you'd like to, and that will get you access to the source code. I push it basically right after the stream every night, so right away you can get access to it. And we will be putting the art assets up as part of this pre-order as well, so that if you want to follow along with the art assets we use once we start doing graphics and sound and stuff, they'll be in there too. And I think that's about it. I've got some notes that I wanted to talk about in the Q&A, just some cleanup from before. But I will look at questions first, and we will talk about those as time permits. Okay, let's go to the Q&A. Please prefix your questions with @cmuratori if you can, because that is the only way that I will see them, because I've got a little scanner that scans them. So if you want me to answer the question, then you will have to put that in there. So please put that in there. Let's take a look here. Someone says, seems unsafe to include the platform-independent code after including the platform-specific headers. Yes, that is true to an extent. When we clean this up, and we could do this right now, actually, you can already do it if you'd like to. You can definitely do stuff where you sort of change the way these definition orders come. So for example, you can do something more like this, and of course you will still need the standard definitions of the types because we were using those, so we could move them down. If you wanted to move them like this, right, it would still work just fine. And the reason for that is basically because if you do not trust yourself, or even if you trust yourself just fine, but you don't trust Windows, and that is a pretty reasonable thing. Windows defines a lot of stupid macros and stuff that override stuff in your code, for example. So if you want to be a little more isolated, and this is probably something I would recommend as well, we just hadn't gotten there yet, since it came up in the question, we might as well talk about it now. Putting as much of your code above the Windows include as possible is usually a good thing. There's no reason to put that stuff in here, because we really should just leave all of our platform non-specific code outside of it so that it can't see any of Windows and isn't bothered by it. Because remember, we're basically creating one giant file. We're basically creating one giant file filled with pound includes that's just all the code. And so rather than pound including Windows at the top so that everyone can see the stuff from Windows, you might as well put it at the bottom so that nobody gets there. I wouldn't necessarily call it unsafe. I think the person who asked the question said unsafe, but of course he did put it in quotes. I wouldn't say unsafe, but it is just probably better practice not to, because again, Windows can define pound defines and stuff in there that you don't want interfering with your code, and so it's probably just better. It's less aggravating, because otherwise you're going to go to there somewhere and you're going to call something like, I don't know, like create directory. You're going to make a function called that and then find that your code goes all wonky because Windows has pound defined it to be create directory A or something like this, and it's messing with you. Let's see. Would you always orchestrate how you do threading in the platform layer, or does it make sense for the platform layer to also provide a more generic threading job service? So I always would orchestrate it in the platform layer, and the reason for that is because you don't really know how the platform wants to handle threading in that way. It may threading oftentimes in games. Oh great, my cord has caught here. There we go. Threading oftentimes in games is directly tied to resource management in a lot of places. So there's threads that just do computation stuff, and that's fine. But there are also threads that are tied to servicing resource readiness. File I/O, network I/O, things like this. And a lot of times you really need that to be an integral part of your threading scheme. And so I find that keeping that stuff in the platform layer is better. If there's something that every single platform is doing the same, then that's a perfect candidate for hoisting it out into the platform non-specific layer. But really the meta thing to say is basically don't move anything into the platform non-specific layer that is actually different on each platform. So if you go ahead and make open window into a virtual thing, like I was saying before, not virtual, but a thing that your actually game is calling, that suggests that there's some bonus in saving the fact that a window is going to be open so that you don't have to do it multiple times. But you're going to do that in every platform, and in every platform it's different code and a different procedure. So you don't actually gain anything, you just add complexity by having it have to ping pong back and forth. So really what I try to do, and the reason that I like the secondary method better, the method where it's just a strict service layer back and forth, is basically because it gets rid of all that cruft, all that extraneous unimportant interface. Let's see. You said last stream that you didn't really like showing the FPS because you didn't find it useful. Can you explain that? Yeah, it's because it's an inverse number. I don't really like thinking about it because you're like, how many cycles did that code take? How many milliseconds did that code take? That's like a direct measured thing. And so you're just talking about the thing that you actually care about. But with frames per second, it's like 1 over that thing, right? If your game took 14 milliseconds to render, right? I mean, well, here, it's really easy to sort of show you what I mean, right? So basically, maybe, oh, you know what? I think I might even have, do I have LibreOffice Calc on here? Okay. LibreOffice Calc. Open me up. There it is, the Document Foundation, ladies and gentlemen. I don't know what that is, but they make a free spreadsheet, and I thank them for that. So let's say we have milliseconds and frames per second, right? So let's look at what the milliseconds are for our game here. Let's just say we basically have everything from like essentially extraordinarily fast, way higher than any game will ever run, all the way out to, let's see there, something like 30 frames a second, right? 30 frames a second is pretty common. So I'm going to say that we basically have 1 over, right, or sorry, I should say 1,000 milliseconds over that, right, over the whatever the millisecond is. And so this is how many frames per second we should be getting, right? And then I'm going to turn off all the crazy decimal points there so you can kind of see what ends up happening with our number. Format cells, let's see, like that. There we go. All right. So what you can look at here, and hopefully this will make a little bit of sense, is let's say that I sped up my code. So I actually took a piece of code that was taking 4 milliseconds, and I sped it up by 2 milliseconds. So I cut out a fair bit of time. So I went from 4 to 2. Well, that's 250 frames a second to 500 frames a second. So if you looked at that, you'd say, oh, 500 minus 250, right? 500 minus 250, that's a difference of 250 frames per second. That's massive, right? Well, let's say I did the exact same thing down here, right? And I sped up code that took 33 milliseconds to 31 milliseconds, right? Well, that was like saying, oh, I went from 30 frames a second to 32 frames a second, right? 32 to 30, or so I'd say 30 to 32. That's a difference of 2 frames per second. The same speed up in code, the same reduction in number of cycles executed, results in 250 frames a second difference versus 2 frames a second difference. So the fact that it's an inverse number creates this nasty thing where you don't even know what you're talking about. Oh, I got 3 more frames per second. Well, out of where were you when you started? I need to know that to know whether that was good or lousy, right? It might be awesome or it might be irrelevant, right? So talking about milliseconds is just way easier because it talks about the actual thing you actually cared about, and it lets you know how impactful that change was, whereas looking at frames per second is just confusing. So I wouldn't necessarily say don't use them. If you like using them, you can use them, and if you understand them well, then that's fine. But that's why I don't like frames per second. I really only ever print out frames per second at the end of things so that I can translate that into whether we're hitting 30 or 60 hertz, because those are industry standard benchmarks. Basically, you've got 3 levels you're looking at. You know, if you're a game, you're looking at these 3 breaking points here, right? I don't know how to highlight those. These are your 3 breaking points for a game. You've got 11 milliseconds per frame. If you can hit that, you can run in VR. You've got 60 milliseconds per frame. If you can hit that, you can lock 60 hertz on it. So a 1080p, nice, smooth display. And if you can hit 33, then you're at least nice and smooth. You look animated, you're 30 frames a second. Anything below that, and you're totally, you're done. But those are your 3 breaking points, right? And so, I just find it easier to think about the milliseconds there, and then just use these as kind of guidelines for when you're talking about industry numbers. You can kind of remember, oh yeah, like, what frames per second am I at? Because that's what people quote. Hopefully that answered the question. Okay. On the scale from genius to totally awesome, how can you remember all this? So it is really not a scale of genius to awesome as well. It is basically just the fact that actually I'm making tons of mistakes. And that is exactly what will happen to you too when you learn all this. I misstate things all the time, or my knowledge is out of date. Things in the computing world move so fast. So I am telling you the knowledge that I've built up over 30 years. So it seems like a lot, but basically my knowledge is always a little out of date. And every last little thing we do on the stream, with perhaps the caveat of the architecture, which may be more of a timeless thing, at least in C and C++. With the exception of that, like, it appears that I know what I'm talking about because I'm showing you lots of things and they work well. But there's always better things than what I'm showing you because someone just invented a new algorithm that's better in the cache, and because processors changed the way they did it, and so the way that I used to do it is now not the fastest way anymore, or I didn't even know the fastest way at the time because someone else had it. So basically what I would say is try to consider the things that I'm telling you. They may sound impressive when they're coming out because you don't already know them, but really there's way more genius down the line. And so if you have time as you learn these things to read more about them, you will find that there is real genius behind these things that you can do that's more than what I'm doing. And I would highly recommend that you do that. I'm basically giving you the first pass overview that's not so genius. It's just the whole picture. It's like, here's how you do everything reasonably. And then for each individual part, you can go spend a lifetime learning about that one part and being the real genius at it, and you will write code much better than me if you do that. I guarantee you that pretty much anything you pick in here, if you go dedicate 5 years to mastering it, you will be writing code far superior than the thing that I show in this stream, without question. Because there's always that much to learn, and there's always hardware improvements and changes that radically shift the right way, or I shouldn't say the right way, but the best way to do something. And so there's always an expert, and if you want to become an expert in that thing, the things that I'm saying that you are flatteringly calling genius now, you will think were just stupid and misguided when you become an expert in that thing. Do we currently have a hidden platform dependency inside the bitmap memory, or is BGRA something that happens on the other platforms too? So we do have a little bit. So basically what I would like to say about that right now is you could totally do the game this way, and it would not be a problem. Every platform will be able to display a BGR or an RGB XX bitmap for us. However, it will in the future, and in fact I can put a note here for anyone who wants to know. In the future, rendering specifically will become a 3-tiered abstraction. I'll just leave that as a little mystery note, but basically all I'm talking about is the fact that rendering, because it is so time critical and so crucial to the performance of your game, oftentimes goes through one more sort of specialization than everything else does. Nothing else in your game will probably need to be specialized in any more ways than that. But for our game, we will actually be doing something eventually that will introduce one more sort of permutation in our abstraction layer just for graphics. And what that will be is basically sort of a display list abstraction kind of a thing that allows us to either do the rendering ourselves or do the rendering using hardware. So I wouldn't worry really at all about how portable this thing is in terms of speed. It will be portable everywhere in terms of just running okay. But in terms of the speed, which is the only time you would care about this, because the platform layer can always just flip, swizzle the bits on a flip, and swizzle the bits when it blits. It's kind of a good rhyme. Swizzle the bits when it blits. So you could basically always do that, and it would just be a slight performance penalty or something, right? But probably not even there. But we will actually be taking pains to go far beyond that in terms of platform accommodation. So that's the reason that I'm not talking about that right now. But in some sense, you are kind of right. It's not really a platform dependency, it's a platform inefficiency. It's basically saying we're specifying something to the platform layer that we kind of know might be more costly on some platforms than others. And that is not quite the same as a platform dependency, because a dependency suggests it would be very hard to overcome it on other platforms, but that's not really true. So it depends how you want to see it. But either way, we will not be actually leaving it this way in the future. We will be introducing one more thing because we'll need to in order to take advantage of GPU. The sound, on the other hand, will actually probably remain locked. But that will be fine because almost all platforms can output sound in the way we're going to output it. So it's really not that big a deal. And sound is so small that you don't care about the extra buffer copy. Let's take a look. It seems like your approach to handling platform-dependent services is to prefer a many-to-one relationship instead of a one-to-many. What I mean by this is to prefer having the game be the one actual service being provided to different platforms instead of the game being reliant on many different platforms for services. It seems like your approach is advantageous because the game is in fact the one common service being provided and is therefore easier to properly implement for all platforms instead of coming up with some high-level abstraction which might hide some platform-specific issues. Do you agree with this description? If so, do you find this approach to work for API design in pieces of code other than OS-level services? That is a fantastic summary. It is correct, first of all. That is a very good way of saying it, and I would agree with what you said. And I guess the thing I might add to it is at the end there where you're saying, do you think it's a good approach for other things? It is an approach that works very well when you are trying to do something specific. And that is the reason why it works. Basically, the reason why you have this API design benefit, or at least what I'm calling a benefit in my opinion, the reason that you get this API benefit by doing it the way that I'm suggesting rather than the standard way of doing it is because there is a massive disparity in the necessary flexibility on either side of the API boundary. So the OS is fantastically flexible, and the game is not. Games use a very small subset of the features of a normal operating, of the flexibility of a normal operating system. So when you have that very dramatic disparity of a huge amount of flexibility on side A and almost no necessary flexibility on side B, then that is really the time when you want to think about doing that kind of inversion. And instead of propagating forwards the sort of abstraction, you want to propagate it backwards and say, this is the service, let's turn it around. Let's make the simplest thing the service. So I don't know how useful that will be in other circumstances, but if you do find yourself in a place where those sorts of things appear to be true, then it probably is a thing to consider and to at least try, see how it would look. Because you may find that it works as well as it does in games, where I think it does work rather well. Let's see. How did you set up Visual Studio to have that black theme? When I installed it, it popped up a window that said, what kind of theme do you want? And I picked dark. That was all I did. I have no idea. That was it. I then went and tuned my fonts to be the same colors as Emacs by using the font selection in the options menu, but that was the only other thing I did. During coding, is it easy to discipline yourself to make the code as clean and tidy as possible? What it actually does is it encourages OCDness in coding. Do you think this is good in general, or could it backfire? I'm not sure I totally understand the question, but what I would say is I find that the right balance is definitely compression-oriented programming, like I say. I know that's a term that I sort of invented, so it may not be the right one. Like, there's a lot of coding methodology speak out there, and maybe there's a better term for it. I call it compression-oriented programming. Maybe other people would call it something else. But basically, some people sometimes use the word refactoring, but I don't like that because refactoring is talking about other things. And so I don't really like using the word refactoring because I think it implies too much. But you could maybe say refactoring-oriented programming. I don't know. I prefer compression-oriented programming. Basically, what I like to do is I like to see how things go when you just write them sloppily as you want. And then you look and go, what are the commonalities here? How can I reduce the size of this code by pulling out common things into reusable portions and calling them? That is how I like to do things. So I don't really like to be too OCD. I am OCD about some things, to be sure, but I try not to be super OCD about stuff. I try to let things have some breathing room, and then I pull stuff up as they need to be. Now, one thing I will mention is you don't want to compress things too much. You don't want to lock things down too early. So it's important to always have some breathing room, some flexibility in your code. You want to be able to allow it to move a little bit. So you don't want to like every day look through your code and go, let me lock this down to the minimal thing and pull out every last bit and optimize it and all that. That's bad because your code is a living thing. It sort of grows over time and changes. And as you see more about the problem space and you need your code to do different things and do more things, you need that flexibility. So you don't always want to optimize even just at the API level for the specific thing that you're doing. You want to always keep in mind that code needs room to grow and mature. And so too much OCD-ness is bad, certainly. And I would say that it can backfire if you do become too fixated on that sort of thing. Yeah. What did you declare a function before pound define in your header file? I'm sorry, Hayden4, I don't understand what did you declare a function before pound define in your header file. If you could clarify that question, I will answer it. Let's see. I'm very curious, and do you think this would have much cookies into the file? I'm sorry, I do not even know what that means. I cannot understand the question, Marvel Sidekick. Let's see. Onion Knox, that question is not really appropriate for what we're talking about right now. We will be dealing with stuff in terms of asset importing probably next week, but it won't be 3D. So we're not doing 3D assets this time around. Sorry about that. Will we be writing our own image format and loader? Asked Ray Garner 13. Yes, we will. But it will be a pretty simple image format at first. It will not be compressed or anything. It will just be the basics, just so you can see how that works. So it won't be anything fancy, but it'll be there. Let's see. Trying to separate things into questions that are actually about what we were doing, rather than talking about things that we'll probably get to later. I don't really want to answer questions that we're going to actually have whole episodes about in the future. So if you could try to make sure the questions are about what we're doing now, not what we're going to do later, because when we go do it later, I will have a whole hour, and I'll tell you all the things that you're asking in the question, actually, and in fact show you. Let's see. Would there be a way to build your platform-dependent code as a separate entity in order to allow you to reuse it in the future? Yes, that is actually basically what you would do. And in fact, what we sort of are doing. If you want to abstract this code, all you have to do is just pull out the pound include here and just do pound include game.cpp, something that's not a specific name. And then from then on, you just go ahead and use the same layer everywhere on every game. That's it. There's nothing to it. There's nothing platform specific. There's nothing game specific in the platform code ever, really. So yeah. I mean, and I should also state that's how I do it too. I never write new platform layers. I wrote one and I use that one, and periodically I improve it. Let's see. Will you be developing your own implementation of strings? Probably not, because we probably won't use any strings. We will have to deal with strings a little bit for language. Like we'll have to abstract some string stuff for language support when we have strings that appear in the game, basically, for basically shipping with locales. But that's about all we'll be doing. There won't be any strings. This will not be like the Unreal Engine where there's like 8 million strings nude and deleted every frame or whatever happens there, craziness. This is like there won't be any string passing in the game or anything like that. Let's see. Does the Unity build approach work with parallel compilation? I don't know. Basically, the compiles are so fast usually when I do this that I haven't had to worry about that. But I don't know how many compilers are actually multi-threaded inside a single file. They may require you to have multiple files to make that work. And so you would have to break up into a couple different compilation units if you wanted to get parallelism, one basically for every processor. But I don't know. Like I said, the builds are so fast with the amount of code you need for a game. Like this game will probably always compile in less than 10 seconds without multi-platform, without multi-core support, I would think. So we'll see as we go, though. Let's see. Given your Unity approach, correct me if I'm wrong, but I believe you lose multi-threaded compilation. Okay, so that's another one. Yes, I think you do. I mean, I don't think you can get multi-threaded compilation because most compilers aren't multi-threaded inside a compilation unit. I don't actually know. But again, yeah, I don't care because it's fast. It's so fast already that it hasn't actually ever been a problem for me. Why use static functions when there is only one translation unit? So I don't know if you need to do that anymore, but I had found at times in the past that the reason to do it is because it lets the compiler know that it doesn't have to actually build an export table for those functions, and it just speeds things up because now it knows that they're never going to get called externally. It also can sometimes help the optimizer because now the optimizer knows every possible place where the thing is called and knows that it can't ever be called from outside. So it's basically better for the optimizer and the compiler usually. But whether that translates into real savings these days, I don't know. I haven't really tested it these days. Back in the old days, I did some testing on things like this, but I haven't done it recently, so I'm not sure. Let's see. In the Q&A part, could you please read the questions more slowly or re-explain the question after you understood it? This is very important for archived videos. Yes, I will try to do that. That is a good idea. Hello, sir. I'm a computer science student, and I was wondering if you feel that it is necessary to make a flowchart before coding, or if you go with the flow. Well, I certainly don't want to start a holy war. So all I will say is that I have never found it useful to do any kind of diagramming prior to programming because at best the diagram is simply the code that you would be typing and anything less than that obscures the actual reality of the problem and means when you go to actually use that chart it will be wrong. And so I've always found that the right thing to do is to learn to have a good enough cognition of how code works when you look at it, that it is essentially as easy as working with something like a flowchart, but now you know that absolutely everything is captured therein, and you do not get into the circumstance that I often see people get into where they have drawn some diagram or have some crazy UML thing, and then they go to implement it and it's just a mess because the UML diagram fails to capture all of the important subtlety in how the code really works at a low level. I think the question was why the pound define part of the include. Okay, thank you for clarifying that. Pseudonym 73. Okay. I did not talk about these. They get automatically inserted by my editor macros. So if you look at the H file that I made here to store our platform layer definitions, right? It has this thing in here, this pound if. What that's called is it's called a include guard. What it means is that if you try to pound include this file, it'll do this if and see has anyone pound define handmade.h. Assuming that they haven't, it'll actually have this code. Then it will define handmade.h and end the end if. If someone then comes to pound include it again, then you won't actually have to worry about that because it's prevented from being included twice. It'll say if define handmade, and handmade has been defined, so it doesn't include it. That's it. It's just called an include guard or an idempotent. There's weird names for it, but all it is to make sure that if someone in the code, let's say for example, handmade.cpp, it's including handmade.h, right? Let's say we included handmade.h as well beforehand, right? So now it's included twice. You can see that it still works. if I were to go in here and remove these guys so that it actually does get included twice, now you'll notice you get all these errors because it gets included twice and it tries to redefine things, and it's like you can't redefine things twice. That's all. Hopefully that's pretty clear. Yeah. Why do you specify void in function definitions when they don't take arguments? That is just a force of habit. You used to have to do that. You do not have to anymore. So if you would like to, anytime you see me do that, and I guess I don't have one at the moment, but there we go. If you see this, right, this is the way I've written the code, you can equivalently do that if you want to. Similarly, I do this by force of habit, where I put a parentheses around there. You actually, that is the more common way, and perhaps even the more correct way, you might say, to write a return statement. Those are just ways that I code, they're based on the way I learned to program. So there's no real reason for them. They're just a force of habit, and it's not necessary. You don't have to do those things. Okay, last couple questions here. Let's see. Do you have a specific method of solving programming problems where you just write things and solve them in place? Solve them in place, unless they're really hard and I have to think about them for a while and go make sort of like mathematical diagrams or something where I'm trying to work out how something's going to work or something like that in terms of like some other thing like math and not code. If it's a code problem, I do it in place. Let's see. Why are we forward declaring game layer functions in the header when you include the whole implementation? Because I just like to see it. I like to be able to have the H file up and the other thing up. I like to be able to see these. So oftentimes I will do stuff where I actually have, files for my convenience. It's the only reason I break up the files too, because you could just write all the things. You could have basically one file for the whole game, one file for each platform layer, and that would be it. But I do break it up into multiple files and just use pound include to pull them together because I find it's just easier for me to work with when I'm actually editing. Let's see. Let's see. Do you think it's realistic for someone with awful math skills to be an efficient game developer? All right, so I'll end on that question. We will end the stream on that question. The question is, do you think it is realistic for someone with awful math skills to be an efficient game developer? So that is a very complex question, and I'll talk about it for the next 5 minutes, and I do not claim my answer to be definitive. I'm simply going to say my thoughts on it, and I think other people would have different thoughts on it that may be as good or better than the thoughts that I'm about to give. So you can make an entire game with no math skills at all. Okay, that's just true. It is definitely possible to be a very effective programmer in a lot of areas and not know any math. To give you a very simple example, if you were programming a text adventure, it could be possible to make that entire thing very well and do a good job on it, knowing only enough math to do pointer arithmetic, which is like simple addition and understanding addition and multiplication, basically. So at a base level, I would say that we could start out saying that math is not as required for programming as a lot of people make it out to be. That is true. Second thing, a lot of times, in fact, I was listening to something the other day, I was listening to an NPR story where they were talking about like the history of sort of people in computer science and so on, and they were talking about a bunch of things, and they sort of made this implication. They were talking about people who used to be programmers and stopped, or various types of disciplines and these sorts of things, and they made this very common assumption. The NPR interviewer, someone who doesn't know anything about programming, made this very common assumption. They said that a particular person, referring to when they were a child, was very good at math, so they should have been someone who would be very good at computer science, right? And that's a very common feeling among people. I think they think of those two things as related. Where I probably depart with most people is that I think that that being a good programmer, if you're talking literally about programming, it has almost no relationship to how good you are at math. I think they are completely unrelated. And I say that from my own experience because I was absolutely awful at math throughout my whole time going to school. You would never have called me a star math student by any stretch of the imagination. And the reason for that is because a lot of what determines whether you're good at math all throughout a large chunk of the math career is how meticulously you can do things without making mistakes. That's what math almost entirely is from, for your first, I don't know, N years through it. Probably even when you get into college, it's still that way for a long time. Programming, there's no such thing as that. In programming, the computer is doing the work. It's entirely about the logical way in which you break things down, which has a lot more to do about seeing creative analogies in things. It's a lot more like someone who is really good at explaining history, for example. I would peg them as the person who might be better at some of the things in programming. Now, it's not sufficient, certainly, but I'm just saying I wouldn't use math as the primary thing. Because math tends to be about very meticulously executing a small number of logical things with a small number of things in play at any given time. That is what you do in math for your first 16 years of math. But programming is about not having to be meticulous, about a huge number of things that are in play. And the more number of things you can remember and keep in play and analogize and compress and compact and reduce into more convenient ways of thinking about them, the better you will be. Now, other types of math are about these things, right? And so as you get up into higher math, you might say that they're much more related. But the kind of math that you experience in high school, in junior high, and lower certainly, and even probably in college, I find to be completely unrelated to programming. They do not feel similar to me in any way. So that's the second thing. Those are the anti-math parts of the thoughts. The things that saying like, I don't know that being good at math really has all that much to do at being good at programming. Now here's the pro-math parts. Especially in the realm of graphics and sound, which is a really, really important part. And graphics, I should say physics as well, because graphics and physics are kind of tightly coupled in that way. Graphics, physics, and sound, the degree to which those disciplines, when you code them, lean heavily on mathematics cannot be overstated. There is so much math involved in doing, say, 3D graphics and 3D physics. So much math that if you are uncomfortable with conceptual mathematics, not necessarily computation, but conceptual mathematics, I think it is safe to say you will have an extremely hard time doing those parts of the code. It doesn't mean you couldn't maybe do other parts, but when you get up into there and you start talking about programming a 3D game, even the game code, so not the engine code, but even the game code, like how characters work and stuff like that, even that, it is definitely something where not being comfortable with conceptual mathematics, linear algebra, partial differential equations, basic trigonometry, trying to think of the other sorts of things, basic calculus, obviously. Just understanding those things is crucial to being effective in those disciplines. So while if all you want to do is be a good programmer, I don't know that math comes into it very much. If you want to be a good programmer in games, then unless you pick a very specific subgenre of games that doesn't lean very heavily on any of these sorts of things, like narrative 2D games, maybe, I would say that you will have to get familiar with the math and get comfortable with the math. The good news for people who are afraid of that is, like I said, I was awful at math in high school. I had a very hard time with it. And I taught myself linear algebra out of a book. And I taught myself differential equations to the extent that I even know them at all out of books. I taught myself all the trigonometry that I know now out of books because I forgot most of what I learned in high school or just was bad at it in high school. And what I will point out about that is that when you have two things, A, the motivation to do it, because now you have a game that you want to make and you want to make the game good and you are motivated to learn the math behind these things and not just sitting in a classroom somewhere while somebody talks at you and says things that don't mean anything to you. When you're actually motivated, and two, when you have the computer to lean on to do a lot of the work for you that's the drudge work, meticulous work, it really turns things around in terms of your ability to get better at math. You can also use what's called a computer-aided algebra or computer-aided mathematics. I don't know what they're called usually now, like things like Mathematica or MATLAB, these sorts of things. There's even like a free one, I think, that GNU ships. I don't remember what it's called. But basically, you can even have it help you solve equations if you're the type of person who, once you know how to solve an equation, you still have trouble because you forget the minus sign or whatever. There's even things that can help you with that. And so what I would say is, don't give up hope if you want to be a game programmer and found math very difficult in high school. You may find that you are able to go much further in a different setting. I can't promise that you will. You may have just been born bad at math. And if you are, I apologize. There are certain things you just won't be able to do. It's sad, but it might be true. But it may not be true, and so I would definitely give it a good long try. And I think anyone who really puts their mind to it, unless they just somehow were born without any ability to do that concrete thought necessary to do it. But I think if you can learn programming, you've got that enough of a concrete part of the brain that you should be able to learn the math. So what I would say is it's probably going to be more about your determination to do it and less about the impossibility of it. So I would highly recommend saying if that's something you really want to do, use games as a motivation to learn that math, and you will be able, I think, to learn it in that setting if you really put your mind to it and dedicate several months to practice, even if you couldn't do it in school. Because I had a horrible time in school and I hated math in high school. So, all right, everyone. Someone is also saying GNU Octave and GNU Sage, they were saying. So there you go. So that was the thing that I was thinking of, the GNU Kun. So, all right, I think that is the end of the stream for tonight. Thank you so much, everyone, for joining us. I had a wonderful time talking about cross-platform programming with you, and I cannot wait to talk about it some more tomorrow, 8 p.m. Pacific Standard Time. I hope to see you on the stream. And on our new forums, too. If you happen to go check it out, handmadehero.org has the link if you would like to jump over there. Hope to see you there as well. So thank you, everyone, so much for joining me. And also, obviously, tonight, a very special thanks go out again. I thanked them at the beginning of the stream, and I want to thank them at the end again to the people who made the forums possible. In fact, their names are baked into the forums now and will be so forever. We could not have done things like that episode guide without the hard work of people who were really eager to help out with Handmade Hero, and I really appreciate that. Same thing to the people who've doing the platform ports and stuff like that. It's been awesome, and it really helps out other members of the community. So thank you so much, everyone, for doing that again. And thank you all for making Handmade Hero such a great thing. I've been really enjoying it, and I can't wait for the rest of this week and the rest of all the weeks. So thanks, everyone, and I will see you tomorrow night.